All right, welcome everyone. It's great to see everyone here. I just want to quickly echo what Tim said. The community is very important to all of us here, so I'm glad to be a part of this, and you guys can lend the time to me to listen. So tonight I'm going to talk about TypeScript decorators and metaprogramming. So everyone uses decorators regularly. This is an Angular meetup, so I'm just assuming we've all used Angular even in the most basic form. Angular uses them throughout their core application everywhere. It's component, injectable, ng module, pipe, those types of things. So when you first start Angular, everyone probably went through the Tour of Heroes. This is the tutorial that it's actually a pretty full-featured app. You build this superhero roster, and the very first file that you open up is appcomponent.ts. This is what they have you, very first thing that you see. They have you change the title, but that's kind of basic. But the largest amount of code on here is actually a decorator. That at component on line 4 is a full class decorator, it's called. They don't actually explain it, and you never actually go into doing anything with decorators in the whole tutorial, even though you actually use pretty much everything, and you can create a full-featured app after you do that. The reason you don't do that is because it's a very good API that it sets up for you, where you don't have to understand what it's doing, and you can just use it and build everything. So what I want to do tonight is just talk about what they actually are, how to use them, what they are doing, and then how to write your own. So first, what are decorators? The TypeScript docs are really vague on what a decorator actually is. It'll say something that it's a special kind of declaration that can be attached to a class or a method. So it doesn't really tell you too much of what it is, just kind of where you can put it. I saw another thing write that it's a clean syntax for wrapping a piece of code with a function. So again, that one's not that descriptive, but that one's actually a little more interesting because decorators are just functions. Don't think of them as anything else besides that. They are very simple, straightforward functions. They'll let you put some logic into that function and encapsulate it away from other portions. Just know that they differ from JavaScript decorators. Right now, decorators are a stage 2 proposal for ECMAScript. So once that standard gets adopted and then moved into JavaScript, it's likely that decorators will be different than what we see in TypeScript right now. So just know going forward that we're only going to talk about TypeScript's implementation tonight, and down the road, this might change. And also, they are actually only experimental in TypeScript. We don't really notice anything with that because Angular sets up a lot of work for us ahead of time. But if you went and made your own TypeScript project, you would have to set up the compiler a little bit just to make this work. We won't go into any of that because we're going to just assume that we're using Angular and the work's done for you. So let's just talk about what type of code can be decorated. Now this is a very basic class with no decorators in it. It's as simple as it can be, and it's a basic dog class. You have a private property, you have a constructor, you have a public method, speak, that takes a parameter message. You have a public getter, full name. So let's just look on this where these pieces of code can be decorated. We'll put some mock decorators in there. So the first one we see, you can decorate classes, and that's what's happening on line 1. You have a class decorator, kind of like we were doing with the component. You have a property decorator that you can see on line 3. You can do all of your properties. You can do your methods, like you see on line 7 for the speak method. And then actually, if you look inside there, inside speak, you can do parameter decorators. And then the final one is accessor decorators that you'll see on the getter. One thing that I want to note, if you look at, the placement of these does not matter. So if you look, the class decorator it's above the class, but if you look at the property decorator, it's right before it. You can put any of them above or before, it doesn't matter, it's just going to be a style thing. There is some convention that people use, but you can do it however you'd like. So the first one I want to start with is a class decorator because that's what we saw the component decorator that you open up with. Now, if you go into the TypeScript documentation, this is the actual class decorator type signature. This will be in your node modules. This will be on their GitHub. It's very easy to access. One thing first to know is that you don't ever reference this. You never need to extend it. You never need to make any references or use this actual class decorator type. The compiler is going to do this for you. When you decorate a class, it's going to know what decorator you're making. So it's kind of a little intuitive. But just know, so if we look at this, it takes in a function. You have a generic there. That's going to take in a function. And then the output, again, is a function. So decorators are very simple. It takes in a function, returns a function. Just know that portion. But the interesting thing is that the function is going to be a constructor when it's a class decorator. And that should make sense if you're familiar with working with JavaScript before ES6 classes, when we did prototypal inheritance and constructor functions, it would make sense that this is what we're working on. But don't worry about that part. Just know that once you're doing a class decorator, you're doing some type of work with a constructor. So let's write a class decorator first. And this is going to be super basic. The first thing that the TypeScript docs show you is this way of sealing an object. And this is going to actually be more simple than anything you'll ever use. So we'll look at it super quick and then move on. But if you don't know, sealing an object just makes it so it's non-extensible. Like you can't add or remove properties from it. So this is as simple as it is. It's just a normal function. There's nothing else on here that says decorator, you need to do to make it a decorator. It's just a function. We have a constructor passed in as the parameter, and we're doing some type of work with the constructor. Here, we're just passing into object.seal, but it's not that complex because we're not changing the constructor at all, which we'll show about a little later. To use it, you simply just use that @ symbol and then call your function. So @sealed on this class, dog. Every time we make a dog now, that object is going to be sealed and we can't extend it. So let's look back at this class we had, and let's try to write one that's actually a little more real. So right now, you can create a new dog, and we have created this dog, Nora, who can speak, and it says hello. You get this output, bark, hello, bark. It really can't do much else. Now, because this is Angular, let's say we want to make a superhero dog, because that's what Angular does for everything. It'd be kind of strange to add a fly method right into the dog class, because not all dogs can fly. It's kind of weird. We could do that with interfaces, inheritance, and some other thing, but that's not why we're here tonight, so let's do it with a decorator. So this is a flyer class decorator that I created. It looks like there's much more going on now, but this is still a simple decorator. This is just a regular function. The first line has a whole lot of kind of complex logic of a generic in there, and that is super boilerplate. You're going to see that right in the TypeScript docs, but just know we're taking in a function and returning a function, both of those being constructors. But that's just how they have it laid out. So then you're returning a class that extends this constructor. So know that we're not actually overwriting it, we're extending it. So we're keeping all of the normal logic we had before, but we're just going to build on top of it. And just like you would anywhere else, we declare this fly method that now has this console log of whoosh. So now it would be able to fly. But just again, remember, we're extending it. This isn't the only thing that it could do. To use this decorator, it's very simple, just like we did before, just @flyer. Now, we have no fly method in our dog class, but now if we go and we create a new dog that is Super Nora, we have a superhero now, you can call .fly on it, and now it's able to fly. We didn't have to go and change the dog class. We didn't put fly in there and make this class be kind of like this super class and do all these crazy things. It keeps the logic completely encapsulated outside of that class, and then we could add it to other classes we wanted to. So this component decorator we saw before still looks a little different from the one we just made. The component decorator has some parentheses, it looks more like a function call, and it's taken in an object. That object that's coming in is called metadata. Selector, template URL, style URLs, these are super common, and that's not all of them. You can add a bunch more, but it's just kind of different data that's going to describe the data that you're working with. We didn't do any of that before the one we just made. So what's happening here is this isn't just a decorator, this is actually a decorator factory. So let's try to figure out what's going on with that. But first of all, what are factories? So factories are not anything to do with decorators. This is a very common pattern in software engineering. A factory, again, a function that returns a function. You put in some information, you output other functions that you can use. It lets you configure these instead of defining all of these different specific functions. So a decorator factory is a function that returns decorators, which are still just functions. The component one we saw receives the metadata, and it outputs another decorator that uses that metadata to create that function. So we're going to write a decorator factory, and this is starting to grow again now. The first line is now taken in this object. We're calling it a speed, and it'll take in some parameters, velocity, and unit. After that, we immediately return. That looks just like the one we made before, because we're returning this decorator instantiation or declaration. So the only difference now is if we look on our console log on line 5, we're actually using that object that was being passed in. So now we have a little bit of configurability, and this is still going to return a full decorator. The first return is the return of the factory, and then the return on line 3 is the return of the decorator. So now we can pass in that object just like we did in the component decorator. Now this starts to look more like that first example that we always see whenever we create a component with ngGenerator or something. Call the flyer, we pass in this object of velocity and unit. What's going to happen is the decorator factory will evaluate, use that object to create this method, and then the decorator will be called to change and add this fly method to the class. So now if we look down at the bottom, we do the same thing, instantiate a new dog, call .fly on it, and now we have a more descriptive output. And we could have configured this however we wanted, and you don't have to have one decorator for each of these configurations. We could do one in kilometers per hour if we want to be able to specify different ways. So now this looks a lot more like component, and this is exactly what Angular is doing under the hood. They're taking in this type of metadata and making configurations where we pass in a template URL, and now this knows where to find this file. It fetches that file and adds that as if you inlined it in the component. I don't know if any of you ever saw, but you can just, instead of doing template URL, you just do template and you type in your HTML right there. This is just a way that it will know to fetch that file and do that for you. So let's move on to a method decorator. We saw there is multiple ways or multiple decorators that you can make. Again, we'll go back to the TypeScript docs and look at this decorator type signature. This one's a little different than the class, so let's walk through what it's taking in first. Your first parameter is target, and the target is a reference to the object that owns the original method. Property key is just going to be simply a string of the method name that you decorated. And then descriptor is going to be how you have access to that original method. That's where you're going to be able to get the value of it and be able to call it and do some type of work with the method that you're decorating. What's interesting, again, look at the type of descriptor and then the return type from the function. Those are the same return types. Because again, we're taking in a function, which is the method that we decorated, and then we're returning that method again, but after we do some type of work to it. So we keep following the same theme of function that returns a function. Everything that kind of comes in is the same thing as going out. And this is where we start getting into that idea of like metaprogramming, where it's just data about data, functions return functions. So let's write a method decorator. The one I wrote is a decorator that logs when a method is called. So it's going to start creating some logging logic. And I wanted to log the method name and also the parameters that you pass into the method. The idea of this is that you don't want to start polluting your methods with logging logic. You can keep this completely separate. You don't want to put a bunch of console logs everywhere and have to change it for every instance. You usually keep logging logic outside of it. So now this is a very simple decorator, but this grew a ton already. And we'll walk through it kind of slow and see what is going on, but it's pretty simple still. We create a function. Again, there's nothing special to make this a decorator. The three parameters we talked about, target is now going to be the object that owns that method. Property name is going to be a string of whatever method we decorated. And then the property descriptor, this is how we're going to be able to make a reference to the method that we created or that we decorated. So the first thing we're doing on line 6, there's property descriptor.value. That's the one that gives you all of the access. Now we store a reference to the original method. Now we can do anything we want. That we have the old method that was originally created, and then on line 7, we're creating a new function. We're redefining property descriptor.value. So what's interesting is we keep this old one, and then we're going to create a whole new method. And we can do anything we want. We could just completely change it, get rid of it. We could do nothing, but now we are going to replace it with this function. Line 8 is just getting a string of all the params that were passed in. Don't worry about that line with decorators of any sort. Line 9 is very interesting, though, because now we're getting the result of method. Method is our original one that we decorated. So now we're going to call our original method, and what I'm going to do is just console log out method called with property name. That's the method I decorated. And then params is just that string I made. We have two returns. Return on line 11 is the return of the method. When you call the method and we call it later, that's what's going to come back and be returned to you. The return on line 13 is returning property descriptor. That's returning the method itself. So line 11 is the return of what's being returned on line 13. It's kind of like you're redefining the method and then passing that method back to where you got it from. It's a little interesting when we think about a lot of the trends we're going into where we do like no mutation of any sort, everything's pure functions in and out. Here we're redefining a lot of stuff. This kind of goes against normal thinking of what is going on right now, but it's just another way of solving problems. But let's look at how we can use this log decorator. This is our regular dog class again. If we look on line 7, we have our speak method, and all we do is decorate log on top of it. Now when we create a new dog, call Nora.speak, we get our normal output, but then also we'll get an output of saying method called speak with the parameter of the string hello. Now that will work for any method we want to put it on with any amount of arguments that are passed in. It's just like very extensible, it's very easy. We don't pollute the speak method with any of this extra logging. Everything is completely separated. Before, when we did class decorators, we talked about decorator factories, remember? You can do that with method decorators. You can create method decorator factories. So again, functions that return functions. That's what a factory is, and a decorator is still the same thing, a function that returns a function. This log is now a decorator factory, and all of it is almost the exact same thing we just did. But our first line, now we're pulling in a Boolean instead of all of those 3 parameters we talked about. The first return immediately is going to be what is going to be the decorator that's returned from the factory. We know what the target property name, property descriptor is. We just said those a few times. We look at the method, gets the property.value, property descriptor.value, we redefine it. So it's the same thing. You take in the method, redefine what it is. The only thing interesting now is our line 11, we just do some work with what was passed in. Line 12, we're going to do method called, include the class name, property name, params. Again, those 2, now we have 3 returns, but those 2 returns, you got to realize the 13, that's the return of the method. This is what's going to get returned. When you call the method, that's what's getting returned to you. Line 15 is the return of the decorator. Line 12 is the return of the factory. So you start to get multiple levels in. To use this will be exactly the same as we saw before, but now we can just pass a Boolean in. So line 6, now we call log, and we just pass in true with it because we know we want to log out the class name is what we're saying. So when we call our method hello, we get method called dog.speak because we had reference to the class name, and that's what was interesting about having this reference to the object that owned the method. There's nothing in this speak method that says what class it belongs to or that string dog, but we were able to introspect up into the class itself. So we'll move on from method decorators. We also said we can do accessor decorators. These ones are very similar, so that's why we'll do these ones now. Again, we'll go back to the TypeScript docs. This time it gets interesting. We start looking for an accessor decorator, and we don't find it. There is nothing in the TypeScript docs, not in their documents about how to use this. When you go through, you realize accessors are getters and setters. That's how you access values. Those are just methods. What you'll use is the method decorator. It's the exact same thing. So you use that same type signature. When we write an accessor decorator, the one I'm going to write is, let's say we have that accessor for full name. We have a superhero. We want to mask the superhero's full name. We don't want people to be able to ask for that. So let's write an accessor decorator for that to protect this getter. What we're doing here, this looks just like the method decorator. Target, that's the object that owns the method, or in this place, the getter or setter. Property key is a string of that method. Property descriptor is how we access the original value of it, the original method. Now on line 6, accessor is equal to property descriptor.get. We called before property descriptor.value, and that gave us the method. Getters and setters are a little different. You have to explicitly say .get because it's not a normal method. It's stored differently. And then we redefine property descriptor.get because now we want to change what the getter functionality is, not what an actual method is, even though they are very similar. Line 8, same thing. I call accessor.apply because I'm calling this same accessor. I want to get the original result from it. And then we're going to just return a new string, definitely not whatever that name was that was going to come back out. It's going to be really secretive. So line 9 return, that's the return of the getter. That's what it's going to happen when you call the getter. Line 11 return, that's the return of the decorator. So let's use this now. We have our getter for full name. We mask that full name. And now the superhero gets created. Somebody asks her what her full name is, and it says definitely not Nora the dog. So now she's obviously safe. No one will know who she is. But this shows that we can go and change the output of it. What if it's something simple that you want to have this output that comes out in like caps or something? You don't want to go change the method that returns the full name every time because maybe you only want to use that in this instance and such. So it's just a way to pull that type of logic outside of it. So we did this for a getter, but what about for a setter? We know that you can have a get and a set for the same member, but what's interesting is this actually won't work, what we have here. You cannot decorate a get and set for the same member like this. The reason this is because property descriptor is what we were using to get that value, and we called property descriptor.get, so therefore the property descriptor is the same for full name, whether it's a get or a set, and we can't just decorate it separately. The correct way to do that is you have to decorate whatever one comes first. So you have to move that onto the get. So both of those decorators go on the getter, nothing goes on the setter. If you had them switched and you had your set first, they would both be on the set. This is the first time we're doing multiple decorators on one thing, and that is perfectly fine. And you can do even more than that, and that is a pattern that is used. But what's interesting is, like, how do these chain? What order do they get called in? What happens in what order? So that's called decorator composition, and let's look at that really quickly. Multiple decorators is actually treated like function composition in mathematics. So if you try to think of that, we have x, and that is decorated by g and by f. If we were just purely in mathematics, we would say f compose g of x, or x goes into the g function. The result of all of that goes into the f function, and that's exactly how decorators work. They're going to be evaluated from top to bottom and then called from bottom to top. So you kind of have this sequential going down and going back up. The best way to look at that is with decorator factories, because you have that different step. And the example I'm going to show you now is direct from the TypeScript documents. So it's a bit longer than I would like, but it kind of describes it the best. Those two functions there are just two decorators that are pretty much identical. Just notice they are decorator factories. They console log out when the factory is evaluated, and then they console out when the decorator is called. And they both do the same thing. So let's say we have this class. We decorate method with f and g. When we use it, you're going to see this pattern where f will be evaluated, then g will be evaluated. We go top to bottom. But then g will be called, and then f will be called. We go from bottom to top. So if you didn't have the factories at all of your decorators are going to be called upwards. Everything goes from your method, original result, up into the lowest decorator, and then all of that result is passed into the next decorator, and you can chain them all the way up. So we went over 3 of them. The final 2 I grouped together. This is property and parameter decorators, and that's because they work very differently than how the other ones work. We're not even going to write our own. We're just going to look at the signatures for both of them real quick, but they are very, very different. So we only have 2 parameters. This is a lot shorter. This is a property decorator. Target and property key, we saw these were before. This will be the object that the property belongs to, and the property key is the name of the property. But what we're missing is a descriptor. We have no descriptor, so we have no access to the values. This is the one that actually let us do all of the interesting work. So you can only use this property decorators to observe that a property of a specific name was declared on a class. You have no access to what the value of that property ever is or was. So it's just knowing that species was declared on dog. We don't ever get the string of dog or that it was changed or anything. So it's only for like some minor introspections that aren't as interesting right now. We have the same limitation with parameter decorators. We get target and property key. This one we also have parameter index, which is exactly that. It's an indexed order that the parameter appeared in the parameter list. So we just know that it was the 3rd parameter, the 2nd parameter. We will still never have a way of knowing from just using this alone what the parameter was. You can start doing some interesting things where you combine decorators and you use property or parameter decorators with method decorators. Here you might have the index and you can like get to the method and know when it was called. You can start chaining them, but for in the basic sense, using this alone, you have very limited functionality. So it's the same limits. We just know that the speak method has a message parameter. We don't know what the value of message ever was. So how does all of this, again, apply back to this topic of metaprogramming? There's a lot more you can dig into decorators and such, but this is just kind of like a overarching theme that I've been finding with decorators. So metaprogram is just a program that produces a program. It's just code that creates code. I always think of metaprogramming with the Lisp language, back to where you could like even pass code around as data. This isn't exactly like that. This is more of just like a syntax that will move some of your work from runtime to compile time, which is interesting to be able to create these more generic factories and decorators that will output this code that you need later. But know that this is just another tool. Don't think of this as this next level dev skill that's going to change everything. This isn't a catch-all for everything. It is just something else to use to solve some of your problems. What I wanted you to get from this is just to know what Angular is using decorators for, So when next time you fill out a template or something, you know why you're passing into this little @ symbol and what you're actually doing. And then how you can start writing some of them yourselves. And this is Nora, of course, who is our dog from our example. But that's everything, so thank you very much.
Thank you, Lee. Any questions for Lee? Oh, multiple.
So earlier when you were describing getters and setters, you were mentioning how the syntax, the signature is the same, but basically how you use it. Are they, I mean, I guess this is more down to maybe semantics, but are they actually different in any way other than how you utilize internally? Or is it just like a label difference that we call them getters and setters?
Yeah, so in decorator aspect or in actual getters and setters themselves? Like in getters and setters like themselves, are they different than each other from methods or like within decorators?
Within decorators.
Yeah, within decorators, the only difference is that you can't call property descriptor.value on it because that's going to call a method. You have to be explicit and say get and set. I mean, yeah, the return value of it's going to differ because getter, you're expecting to always return something. A setter, you're expected to change the value of it. You can break the rules. That's what's interesting here is you could go in there and create this setter and start changing it to do things that you wouldn't normally expect it to do. So that's where it starts to blur the lines. But yeah, you can do all the same things. From the single decorator, you can change both get and set of something because they're just two different values. And you can decorate just the getter, but then actually create a setter on it, even though there's not one there to initially create. It's kind of interesting. Yeah. I think we had one over here.
Yeah, we had one more question.
It doesn't appear there is any way to influence the type system through this. Is there any plan for that?
Yeah, so that's very interesting. That was a problem I ran into. My first usage of decorators was for something like that. I was doing some cache work and I needed to be able to influence the type. I found some ways to do it. I didn't go too deep into it. The property descriptor, there's two different types you can use for that, which is property descriptor and then typed property descriptor, which takes a type in. So using that, you can start kind of manipulating the type a little bit. It's not fully extensible. You can pass in a bunch of types and do a lot with it, but it does start to answer that question a little bit. Yeah.
Okay, thank you. Any more questions?
Thank you very much, everyone.
Okay, thank you, Lee.